In this video, we will compute the surface integral of a vector field over a surface which is given as a graph. So here the surface is part of the parabolic cylinder. Z is 4 minus y squared, which sits above the xy plane and is in between x equals 0 and x equals 1. So let's say here's x equals 1. And maybe here's z equals 4. And here's the parabola, z equals 4 minus y squared. And it goes, drag it in the x direction. So here's our surface. So we have this parabolic cylinder. So here's the surface S, and we want the orientation with upward pointing normal. So at any given point on the surface, we want the normal vector to have positive z component. So it points outward, away from the x-axis. Let's just recall that for a graph, ds has components minus fx, minus fy, and 1. Sometimes you use the negative of that, depending on how you want the orientation to go, but in this case we want positive z coordinate for our normal vectors, so we use this one. And then I suppose we put dx dy after it. Okay. So, to evaluate our surface integral, what we do is for the bounds of the integral, we describe the shadow of the graph. So in this case, it's this rectangle. So it's the shadow of the graph in the xy plane. The projection of the graph down to the plane z equals 0. In this case, it's this blue rectangle, which goes from 0 to 1 in the x direction and negative 2 to 2 in the y direction. And now what we do is we just write f dot ds, but for f, everywhere we see z in the vector field, we substitute the equation for the cylinder. So here's z squared will be 4 minus y squared squared. X is just x. And again we substitute for z. 4 minus y squared. And if we distribute that minus 3, we'll have 3y squared minus 12. Dot. And below we have written here ds. In this case, fx is 0, because there's no x in the equation for the cylinder. Fy is minus 2y, so with an extra minus sign that's 2y, and 1. So that's what we put here. 0, 2y, 1. dx dy. And now we just multiply it out. So if we do this dot product, we have 0 times the first slot plus 2y times x plus 1 times 3y squared minus 12. So we do the x integral first. Integral of 2x is x squared. From 0 to 1, that's just 1. And 3y squared minus 12 is a constant. So if we integrate the constant from 0 to 1, we just get that same constant again. And now we get 1/2 y squared plus y cubed minus 12y. So this one, the first one is just 0. We have an even function. Over an interval centered around 0, so this is just 4 minus 4. Next, we have 8 minus negative 8, which is 16, and minus 12 times 2 minus negative 2 is 4. So we have 16 minus 48, which is negative 32, and that is our final answer.